Morning children. So welcome back to the online session of a mathematics class. So in the last video was interrupted due to technical problem. So I had done up to 7 point, that is classify the following. So which is 9th question. Classify the following numbers as classify the following numbers as rational or irrational. Okay. So I have done the third question. So to the fourth question it was interrupted. So I will go to the fourth one again. That is 7.478. Again 478. Again 478 and so on. Okay, so we need to classify these numbers as a rational or irrational. So now this is the decimal expansion of the number. So by observing the decimal expansion, how to decide that the given number is a rational number or irrational number. So we know that if it is a rational number, the decimal expansion is terminates. The decimal expansion is terminates, or the decimal expansion, that means the digits are repeating or recurring. Okay, so then in those two cases it is a rational number. Then what is irrational number? What is the decimal expansion of irrational number in the sense? It is non-terminating also, and it is non-recurring also. It is non-terminating also, it is non-recurring also. Then it is irrational number. Let me say, this is definitely it is non-terminating only, right? It is not terminating, it is non-terminating. Because it is continuing like this, 478, 478, 478, it is keep on going like that. So that means it is not terminating, it is non-terminating only. But let us see that whether the digits are repeating. Observe that 478, 478, 478, again 478, 478, 478. That 478 pattern will be recurring or repeating. So 478 will be repeating, therefore it is a rational number. So it has non-terminating and recurring decimal expansion. Decimal expansion, because the result is 478 is repeating, right? 478 is repeating. It has non-terminating and recurring decimal expansion. Therefore, it is a rational number. Okay. So it is a rational number. Okay. So we'll go for the fifth one. That is 1.01. 001 and so on. So observe this number, decimal expansion, and tell me whether it is a rational or irrational. Definitely it is non-terminating. It is non-terminating. We'll see that whether digits are repeating or not. Observe that 0. Of course 0 is not repeating. Okay, 0 1. 0 1, again we are having double 0. So that means 0 is also not repeating. 0 1 0. 0 1 0, but 0 0 1. Here it is not repeating. Okay. 0 1 0 0, but 1 0 0 0. So that means 4 digits is also not repeating. 0 1 0 0 1. 0 0 no. 5 digits is also not repeating. That means it is not repeating. Non-recurring. It is non-recurring. It is a non-terminating. It is a non-recurring. So therefore it has a irrational number. Yes. It has non-terminating. It has non-terminating and non-recurring. Non-recurring. It has non-terminating and non-recurring decimal expansion. Therefore, it is an irrational number. It is Okay, we will go for the next concept, which is operations on real numbers. Okay, so basically operations in this is what are the operations? We know that addition, we know that subtraction, we know that multiplication, and we know that division. So normally we know that these four operations, right? So we will be doing these four operations on real numbers. So what is real numbers? Real numbers is a combination of rational as well as the irrational. Okay, so since it is a combination of both rational and irrational, okay, we know that. So this is having a representation p by q, can be represented in terms of p by q. So it cannot be expressed in terms of p by q, which is called as the irrational number, right? For example, if I take root 2 cannot be expressed in terms of p by q, that is numerator and denominator combination. Here if I take that, I'll take 3 by 4. This is expressed in terms of p by q, where p and q are integers and q not equal to 0. Now this is the example of rational and this is the example of irrational. Okay, what about this? If I take root 3, then pi value, then 0 0.0 2 3 4 1 5 4 6 so on. This is also a irrational number. Pi is also an irrational number because pi value is 3.14. 658 will keep on going like that. It is not going to be terminating. It is not going to be recurring also. Definitely, it is a irrational number. Now we are doing the operations on real numbers. Since real numbers is a combination of both. Okay, so it is a combination of both. It is a combination of both rational as well as the irrational. It includes both numbers, irrational numbers also, and then rational numbers also. Before going to the operations of real numbers, let us come to the operation of a rational number and irrational number. Okay, what are the operations will be applicable here and what are the operations will be applicable here? Okay, we know that in the rational number group, right, if you add any two rationals, then again the resultant number is also a rational, right? If you take any two rationals and add it, so look at the resultant rational number, that is also a rational. You have learned that properties of rational numbers in your class 8. Rational numbers are closed under addition and multiplication. Under addition and multiplication operation, rational numbers are closed, right? So that we know that, and associative law, commutative law, and distributive law. These three laws will be applicable in the rational numbers system. And if you remove the 0 in the rational number system group, we have 0, right? So minus 1, 3 by 4, minus 3 by 4, 0, 5 by 6, 3, 5. So it is like that. Rational numbers, it is a combination of all integers, whole numbers, everything, natural numbers. Okay, so it is having to be a new combination, everything. So here I am having 0 also in the rational number system. If I remove the 0, then rational numbers are closed under addition also, subtraction also, multiplication also, division also. If I remove the 0, if I am adding a 0, then it is not closed. It is closed under only addition, multiplication, of course subtraction, right? But it is not closed under division. Why? Because if you take any two numbers, divide it, the resultant number must be a rational number. Then only it is closed under division, right? What is closed under addition? Closed under addition in the sense, take any two rationals, add it, look at the resultant number, that is also a rational number only. For example, take 3 plus 5. What is the answer? 8. This resultant number is also a rational number. You take any of the number, take 0 plus 5 by 6. So answer is 5 by 6. Again 5 by 6 is also a member of rational number. Therefore, it is closed under addition. It is closed under addition. You take subtraction also. If I take subtraction, then it is minus 2. Minus 2 is also a member of rational number only because minus 2 is there in rational number system. If I take minus here, then again minus 5 by 6. Of course, minus 5 by 6 is also member of a rational number, right? So this is true for multiplication also. Multiplication. 3 into 5 is 15. Of course, 15 is a member of rational number. So 0 into 5 by 6, 0. Of course, 0 is a member of rational number. So, therefore, rational numbers are closed under addition, subtraction, multiplication. Okay. Now we will come to the matter of division. We will come to the matter of division. Take any two rational numbers, divide it, and see whether the resultant number is belongs to the same group or not. Okay. We will see. We will take any two numbers. We will take 3 and 5. Okay. We will divide it. Of course, it is 3 by 5. Of course, it is a member of 3 divided by 5. So that means 3 by 5. Of course, 3 by 5 is a member of rational numbers. Okay. Now, we will see 3 by 0. I will take 3 and 0, these two numbers. So, what is the value of this? Anything by 0? 3 by 0. 0 by anything is 0. 0 by 3, this is 0. 0 by anything is 0. Anything by 0, it is called as infinity, undefined. It is called as undefined. This will call it as undefined, infinity. We will call it as undefined. The number is not defined, it is undefined, which is not there in the group. Which is not there in the group, it is undefined value. That is not defined value, it is undefined value. That is not there in the group. Now here it is fails. Here it is fails. I have taken two numbers, I have divided, but the resultant number is not belongs to the group. It is undefined value. So what is the conclusion? Rational numbers are not closed under division. Not closed under division. Suppose assume that if you remove this 0, then you take any of the numbers, divide it, definitely that resultant number is there in this rational number group only. That is the meaning of that. If I include that 0, it is not closed under division. Talking about addition, subtraction, multiplication. Addition, subtraction, multiplication. Even though if I am having a 0, if I don't have a 0, then also it is closed. When it comes to the matter of division operation, if I am having a 0 in that, then it is not closed under division operation. Under division operation. If I remove that 0, then it is closed under division operation. Clear? So that is we will call it as non-zero rational numbers is closed. Non-zero. Non-zero means there is no 0. Non-zero rational numbers are closed under division operation. We will say that rational numbers are closed under addition. Rational numbers are closed under subtraction. Rational numbers are closed under multiplication. But rational numbers are not closed under division. Why? They are having 0. If I remove the 0, then it is closed. That means non-zero rational numbers are closed under division. This is the conclusion, right? So, here it is associative law is applicable, commutative law is applicable, distributive law is applicable. We know that what is commutative law, distributive law, associative law. So we have learned lot of things about this distributive law, associative law, commutative law in our class 8. We are having one separate chapter, we have separate lesson, we have rational numbers, right? So we have learned that and we have solved so many examples on commutative law, associative law and then distributive law. All this law will be applicable with the rationals, right? So here it is applicable. As well as here also it is applicable. Commutative law, associative law and then distributive law is also applicable in the rationals. Okay? But the thing is, if you add any two irrational numbers, then also it is irrational number. Can you say that? Can you say that irrational numbers are closed under addition operation? What it means? Take any two rational numbers, any two irrational numbers, add it, look at the resultant whether the resultant number is irrational or not. Okay. So we'll see that. I'll take, for example, I'll take root 2, I'm adding, I'll be taking root 2 and minus root 2 as 2 irrationals. Of course, root 2 is irrational, minus root 2 is also irrational. I'll take 2 irrationals. Root 2, I'll be adding 2 irrationals. Correct? I'll be adding 2 irrationals because I'm adding addition operation. So, root 2 plus minus minus, root 2 minus root 2 is 0. Of course, 0 is irrational. Can you say that 0 is irrational? No, 0 is rational. Now see that 0 is not belongs to this group. What is the conclusion? Irrational numbers are not closed under addition operation. Irrational numbers are not closed under addition operation. Similarly for the subtraction operation. If I take negative sign, then if I take root 2 and root 2, then again root 2 minus root 2 will become 0, which is 0 is not there in the irrational number because 0 is a rational number. Okay, 0 is rational number. Okay, so therefore 0 is not irrational number. So what is the conclusion? That irrational numbers are not closed under subtraction operation. Okay. Irrational numbers are closed under multiplication operation. We will take 2 irrational numbers again. I'll take root 2 and root 2. What is the answer? Root 2 into root 2? Root 2 whole square. Correct? Root 2 into root 2, root 2 whole square. Square will get cancelled. What is the answer? 2. 2 is irrational number? No, 2 is rational number. That means it is fails in multiplication operation also. Irrational numbers are not closed under multiplication operation also. Okay, we'll take division operation. Root 2, root 2. So root 2, root 2 both will get cancelled. 2 1 0, 1 0, 1 by 1 is equal to 1. 1 is irrational number? No, 1 is a rational number. That means it is failed in multiplication operation also, it failed in division operation also. What is the conclusion? Irrational numbers are not closed under addition operation, under subtraction operation, under multiplication operation, under division operation. It is not closed at all. But associative law, commutative law, then distributive law are applicable in the irrational numbers also. Okay, but it is not closed under these 4 operations. Okay. So these are some examples. So it is not true that whenever we are adding 2 irrational numbers, whenever we are subtracting 2 irrational numbers, whenever we are multiplying 2 irrational numbers, whenever we are dividing 2 irrational numbers, the resultant number may be irrational or may not be may be irrational, may not be irrational. For these are the examples. Here we are getting 2 which is not irrational. Here we are getting 1 which is not irrational. In fact, it is which is rational. Okay. So when we are doing operations on real numbers, we are learning about the operations of rational numbers and operations of irrational numbers. So one will be completely applicable. That is, it is both are in both the number systems. Associative law, commutative law, distributive law is applicable in both the number systems. When it comes to the closure property, okay, this is closed under addition, multiplication, subtraction. But if I want division, I need to remove 0. Okay, okay. This is not closed under division. It is under addition, multiplication, subtraction. It is not closed at all. The resultant number may be irrational, may not be irrational. So that is the conclusion. Now, since we are going to do the operation of real numbers, real number is a combination of both rational and irrationals. It is a combination of both irrational and irrationals. Now we will be mixing both an irrational and irrationals. We will be making one group. We will be making one group. Okay. Then we will say that whether the resultant number, whether the real numbers are closed under addition, whether it is closed under multiplication, division, subtraction. We will see that. Okay, and we will do some addition operation, we will do some subtraction operation. We will take one rational number, we will take one irrational number. We will see the resultant number. We will add it, or we will subtract it, or we will divide it, and we will multiply it, and we will see the resultant number. Then what will be the expected number, that we will see. Okay. So that's it for today's class. In the next video, I am going to explain how to add one rational and one irrational. So what will be the resultant number? We have three conditions for that. So sum or difference of rational number and irrational number is always irrational. If I take one irrational number and one rational number, if I add it or subtract it, the resultant number is always irrational number. So like that, we are having three conditions. We will study about these three conditions. Okay. So after learning these three conditions, we will go for some simplifying some equations, both having irrational and rational numbers, combination of both, and we will simplify that, and we will solve some sums regarding this. Okay. So thank you. Any doubts in today's class? Let me know.